Hello, this is Professor Lou from Carolina University, and this is our lecture about lipids. So let's start with some characteristics of lipids. They are essential nutrients. We have to have them. They provide energy. They contribute flavor and texture to food, and they help transport fat-soluble nutrients around the body. So when we're talking about lipids, we're talking about triglycerides, phospholipids, and sterols. So triglycerides are stored in adipose tissue in the body, and they're called fats and oils in food. Phospholipids are found in food of both plant and animal origin, are also made by the body, and are soluble in fat and water. Sterols, the most famous one is cholesterol, is another type of lipid, and we will talk about that when we get to the sterol section. So fatty acids, let's start with those. They're key building blocks. They also determine whether a fat is solid or liquid at room temperature. Fatty acid structure is the basic structure of a fatty acid chain is a methyl end and a carboxyl end. So you're going to see that on this slide. And what's in the middle is how you know whether it's a saturated, mono, unsaturated, or whatnot. So here you have a saturated fatty acid on the top. You see what's in the middle is what is different when you look down at the mono unsaturated fatty acid, an omega-9 at the bottom. And then you have here an omega-6 at the top and a polyunsaturated fatty acid, omega-3 at the bottom. And so that shows you what's different is the middle part here. Saturation is one of the things that's varying there. A saturated fatty acid is when all the bonds between carbon atoms in a chain are single bonds. An unsaturated fatty acid is when one or more bonds between carbon atoms is a double bond. Okay, so with monounsaturated fatty acids, that's when there is one carbon-carbon double bond, and polyunsaturated fatty acids is when there is more than one carbon-carbon double bond. Then we can talk about cis versus trans fatty acids. Unsaturated fatty acids can vary in shape. You got your cis fatty acids where the chain is bent, and that occurs naturally. And we've got trans fatty acids where the chain is straighter, and that's produced by hydrogenation. Hydrogenation is not a natural process. We do that to fats, and hydrogenated oils are bad for our heart. So here you can see illustrations. We've got a saturated fatty acid and a transoleic fatty acid on the left. We've got an unsaturated fatty acid on the right. All right, so let's talk about the liquid versus solid at room temperature, because that is an important point, and it's how we can tell quickly sometimes whether or not a fat is healthy for our heart. If a fat is liquid at room temperature, then it is more likely to be healthy for our heart. If it's solid at room temperature, it's not very healthy for our heart. So why is that? The long-chain saturated fatty acids stack tightly and form solids at room temperature. The monounsaturated and polyunsaturated fatty acids don't stick compactly and are liquid at room temperature. The short-chain saturated fatty acids are also liquid at room temperature. So the healthiest fat is the liquid one. All right, so let's talk about non-essential fatty acids. If something is not essential, you don't have to have it in your diet. It can be made in the body when it is needed in large enough quantities that the body can have enough. So you wouldn't have to consume it. The essential fatty acids must come from food. They cannot be made by the body. The two families of essential fatty acids are the omega-3s and the omega-6. And here you see a little illustration that can give you a little bit of detail about those. You have to make sure you eat the essential fatty acids, and that's one reason they get emphasized sometimes in nutrition information. Triglycerides are the next lipid we're going to talk about. Triglyceride structure is a glycerol plus 3 fatty acids. Most fatty acids exist as part of a triglyceride molecule, okay? So here we have an illustration from your textbook. These fatty acids on the left here bond with one glycerol in a series of reactions. And when that happens, you produce a triglyceride and 3 water molecules. So triglyceride is in the name. It'll help you remember the structure, okay? What are the functions of triglycerides? Energy source, we got 9 kcals per gram. That's a lot of energy, right? That was the most ones, was these lipids. They have the most, 9 kcals. So that gives us a good energy source. Energy reserve, they can be stored as energy in adipose tissue, fat tissue in the body. That helps us have a reserve for times when we're not able to consume as much as we would like maybe winter time in a society where you were dependent on being able to obtain enough nutrients to build up some fat to be able to survive the winter. Then that was really, really important to survival. And then we have some more functions here on this slide. As a carrier of fat-soluble nutrients in the body, like there's certain vitamins that are fat-soluble, and they would be carried around by triglycerides. Insulation and protection with visceral fat. So one of the ways putting on that adipose tissue helps is insulation, and it also protects our organs. Now, nowadays we usually have too much of it, but that doesn't mean that it's still not important as insulation and protection. It's still important. And then we have sensory qualities. Triglycerides contribute to food's flavor, odor, and texture. People say they smell and taste good. So here are the positives of commercial processing of fats. It reduces waste, it prevents spoilage, increases the availability of calorie-rich oils, it removes damaging free fatty acids. Those are actually bad, so reducing them is good. It adds antioxidants to delay rancidity and extend shelf life. This is pretty big. It helps us have crackers on that shelf, right? Because they have to sit there a long time and they have to be non-perishable. And these commercial processing processes actually help that shelf life of food. But there's downsides. Downsides are removes potentially healthy phospholipids, plant sterols, and other phytochemicals. So this increase in processing decreases this type of nutrition. Further processing into solid fats increases the proportion of trans fatty acids. So we know trans fatty acids are bad for us, and when we further process these foods, it just increases that. Okay. So let's talk about phospholipids and their structure. Phospholipids are a glycerol and 2 fatty acids and a phosphate group. And they are compatible with both water and fat, which is very important for their functions, which we're going to see in a moment. So here are the differences between triglycerides and phospholipids in their structure. And here we have the phospholipids functions. They're ideal emulsifiers. They keep fat suspended in water. They keep oil and water mixed. They're a perfect structural element for cell membranes. They're able to communicate with cell entities that are liquid, like blood, cell fluids. They allow other lipids to enter and exit the cells. I think there's an illustration that will help you see that in just a moment. Phospholipids, when they are cell membranes, a double layer of phospholipid is there. Selectively, they can allow both fatty and water-soluble substances into the cell. And they store fatty acids temporarily, and they play an important role in nerve cells as well. So here you have a phospholipid bilayer. So this would be part of a cell membrane. You have your hydrophobic tails. They don't like water. Hydrophobic, don't like water. And hydrophilic head group. So the hydrophilic head does like water. So the phospholipid bilayer is the major component of all cell membranes. The hydrophilic head groups of the phospholipids face the aqueous solution, and the hydrophobic tails are sequestered in the middle of the bilayer. And here you see an illustration from your textbook where it shows the watery outside of the cell and the watery inside of the cell. And you've got the heads are facing the watery sides, right? And then you have fatty acid tails orient themselves away from the watery fluids. And they do that because they don't want to be near the water. I mean, they don't tolerate that. They're not going to interface with that watery side. And then the glycerol and phosphate heads are attracted to the watery fluid side. So they stay on the side interacting with the watery inside of the cell and the watery outside of the cell. And it forms a membrane. And these membranes are essential to hold cells together. The cells, if their membrane is lost, if the integrity of that membrane is lost, then they just leak everything out. And so these cells, they must have this membrane. That's how important phospholipids are for all of our cells. All right, so phospholipids occur naturally in plants and animals, but not as much as triglycerides. They're found in egg yolks, liver, soybeans, peanuts, and are not essential. They're essential in that we have to have phospholipids, but we don't have to consume them in our diet in order to survive. We could get them that way. All right, so sterols have a multiple ring structure, and we're going to see that on a slide or two. Their best known example is cholesterol, and most contain no fatty acids. So here you have the structure of cholesterol. So there are several important functions that cholesterol has. And cholesterol got a bad name in the late 80s. Everybody thought cholesterol was bad, but it actually has some really, really important functions. Major structural component of all cell membranes. So that's important for cell membranes too. A precursor of important substances like vitamin D, steroid hormones, bile salts. So we have to have these things, and sterols are a precursor for them. Cholesterol synthesis primarily in the liver takes place in the body. So in the late 1980s, when we were telling people cholesterol is bad, at least that's the message they received. That wasn't exactly the message, but the public got the idea cholesterol was bad. We were telling them not to eat it in their diet. They were trying to decrease their cholesterol intake. One thing that we weren't telling them was that their body makes cholesterol. And their body makes cholesterol whether or not, they eat it. So their body is still going to have high cholesterol sometimes because their body's making it. And some people are prone to make too much of it or make high levels of it, and that makes them at risk for heart disease, right? So it was an overly simplistic message, and we did change it later. Sterols are found in foods of animal origin, and that's important to remember as well, because the intake of, a vegetarian, let's say a vegetarian that eats eggs and milk, if they're eating a balanced diet, theoretically, as long as they're not eating tremendous amounts of eggs or something, they would not be at risk to have as high a cholesterol from the diet as someone who was was an omnivore eating all kinds of, foods, including meat. But, and that is because sterols are found in foods of animal origin. So a vegan, for example, wouldn't be eating them. And so cholesterol is still made in their body, though. They could still have high cholesterol in their blood. Why? Because their body's making it. They're making too much of it in their case. Okay, lipid digestion and absorption. Let's talk about this real quick. Digestion of triglycerides and phospholipids. Here's the important points. Chewing and lingual lipase start digestion in the mouth, okay? So it's breaking it down. Remember, we talked about that with carbohydrates with a different, enzyme. We had carbohydrates being broken down in the mouth a little bit. And so we also have lipids where the chewing process and then this enzyme helps to break them down. Breaking triglycerides down to diglycerides and fatty acids in the stomach, right? We're having that broke down as well. And then we have bile and pancreatic lipase will emulsify and break down the fats for absorption into the small intestine. And then we have glycerol and fatty acids are absorbed into the bloodstream by intestinal cells. All right, so further, we have digestion of and absorption of sterols. The body absorbs about 50% of dietary cholesterol, so not even all of it, 50% of it. And dietary fat increases absorption. And plant sterols and dietary fiber decrease absorption. So that's why you have Cheerios advertising in their commercials that the fiber content of their Cheerios cereal is going to decrease your cholesterol, because you'll have a decrease of absorption of the cholesterol that's in your diet if you have a high fiber diet. So foods that have a really high fiber content or somewhat high fiber content will be able to talk about, if they want to, that the high fiber diet will actually decrease absorption of cholesterol. If you have a dietary fat, a lot of dietary fat in your diet, then that would actually increase absorption of cholesterol. So let's go on to talk about the American Heart Association recommendations, because when we're talking about lipids, a lot of the interest in nutrition class is going to be about preventing heart disease. So the American Heart Association has recommendations that are consistent with preventing heart disease and also just being healthy. So let's talk about those. It's going to be several slides. The American Heart Association recommends use up at least as many calories as you take in, because many people are overweight or obese. They may need to lose some weight. So they may want to, use up more than the calories they take in. But people need to use up at least as many calories as they take in. Now, of course, there are always going to be exceptions. If you have someone underweight, then they may need to take in more calories than they use because they need to gain weight. But these are recommendations for the whole of society. Eat a variety of nutritious foods from all food groups, right? Heard variety before. Eat an overall healthy dietary pattern. Eat less of the nutrient-poor foods, the ones that don't have good nutrient density. Don't smoke tobacco and avoid secondhand smoke. That may not be dietary, but it's important for heart health. Eat a variety of fresh, frozen, and canned vegetables and fruits without high-calorie sauces or added salt and sugar. Choose fiber-rich whole grains for most grain servings, and choose poultry and fish without skin and prepare them in healthy ways without added saturated and trans fats. Eat a variety of fish at least twice a week, especially fish containing omega-3 fatty acids. Select fat-free, skim, or low-fat 1% dairy products. Avoid foods containing partially hydrogenated vegetable oil to reduce trans fats in your diet. Also, limit saturated fat and trans fats and replace them with better fats like monounsaturated and polyunsaturated. Cut back on beverages and foods with added sugar. And choose foods with less sodium and prepare foods with little or no salt. That is because so many people are getting too much sodium. Further, if you drink alcohol, drink it in moderation. And follow the American Heart Association recommendations when you eat out, and keep an eye on your portion size, because when people eat out, they're often, not following these guidelines, or they're serving whatever's put in front of them instead of paying attention to portion sizes. Okay, so let's talk in a little more detail about the recommended fat intake. So we want to reduce saturated fat, trans fat, and cholesterol. Total fat needs to be 20 to 35% of calories, and less than 10% of calories should come from saturated fat, and less than 300 milligrams per day of cholesterol. Well, less than that. Okay, so it is possible to eat too little fat, even if you're eating some, because we know we need some fats, right? But what if you're eating only 10% of your calories from fat, okay? Fat, just any kind of fat. If you're only eating 10% of your calories from fat, that would be bad. Why? One reason it's bad is you're not going to be able to absorb the fat-soluble nutrients correctly if you don't have enough fat in your diet. That's one reason. Another reason is you might not be able to get enough calories that way, because remember, the fats have more of the calories than the carbohydrates and the proteins. So it's also possible that if you did that, you wouldn't get enough calories, although, that could vary depending on what else you were eating. But the point is, you don't want to eat less than 20% of your calories from fat. And most people are getting way more than that. But you also don't want to go above 35%. And that's what most people are doing in the United States, is they're eating way more than 35% of their calories from fat. They're eating a higher fat diet, and that is contributing to their heart disease and obesity and other health problems. Also, essential fatty acid requirements, you want to get those. The linoleic acid should provide about 2% of your calories, okay? And then also pay attention to the fact that this is a dietary guideline for Americans. Encourages a diet rich in omega-3 fatty acids as provided by seafood, which is a good source of polyunsaturated omega-3 fatty acids, EPA, and DHA, which are substances that we need, okay? So that's an important dietary guideline that is not necessarily being followed much, but we're trying to improve it. We want to increase these omega-3 fatty acids, and so we encourage people to have some seafood, and some people supplement their diet with these omega-3, EPA, and DHA to try to get enough. Okay, so thank you for listening to this lecture, and we'll see you next time for proteins.